All right, this is going to feel more comfortable as we go through it a second time. So now we have mu is the mean pitch speed as before. We wonder, is it different than 75 miles per hour? So our null hypothesis is that the mean is 75, but we want to know, or is it different? So here's different, this one. And so that will be our alternative hypothesis. Now, when looking at your, let's make a box plot this time, just to review a couple of things. So let's make a box plot of this data. So let's insert, let me highlight that. No, our speeds. Let's insert, we'll do a box plot. Okay. So these are pitch velocities. This is velocity. All right, we don't need a title there. Let's get rid of this. All right, and remember that little X. Let's see, for our data, we don't want data labels. We don't need a legend. This little X marks the mean. So we'll just keep that. And you can do different things. Let's make, we want to keep the show means. We want to show the outliers. Let's just put the border a little bit. Okay, so now it shows up a little more. All right, so we're wondering, there's the mean. Is the mean 75 or not? Well, just like before, I don't know that there's convincing evidence about it. It doesn't look like it. It's the same evidence. So does it look like we should reject this? No, it looks like it's a little different, but that's probably just because of chance. So do you believe the null hypothesis will be rejected? No. Do not reject the null hypothesis. Okay. Is your test a one-tailed or two-tailed, where the alternative hypothesis is not equal? It's two-tailed. What is our test statistic? Let's go down and look here. Remember, this is our sample statistic from the data. Sample statistic. That is the sample mean. Let's actually, I didn't ask for that there. And this is the test statistic, saying how many standard deviations we are from the mean. And we said if it's 3, that's a lot. If it's less than 3, it's not, it's not as extreme. It's not as unusual. So we're getting a value that's not very unusual. But our test statistic is a t-value. And the t-value is this. I think, again, I'll write it as 1.6. Okay, what is your p-value? The p-value is this probability, but it's two-tailed, so this is our p-value. Let me just capture that. All right, and that's a little overkill, so we're just going to write 0.11. Should you reject it? Well, we're going to reject if the p-value is less than 5%. So what this is saying is, even if the null hypothesis is true, we're going to see data like what we saw in our sample 11% of the time. That's not unusual. So should we reject it? No. It's not bigger than 5%. Do not reject the null hypothesis. Now let's interpret the p-value. The p-value always has this structure. So assuming the null hypothesis is true, assuming the mean pitch velocity is 75 miles per hour, the probability of seeing sample data like what you said. So the probability, the sample mean is What is it? 75.6. So now we're talking about being different from 75. So it's not just 75.6 or greater, it's 0.6 above the 75 or 0.6 below the 75. Let's call it 0.7. So the probability, the sample mean is within, I say, is more than 0.7 miles per hour from 75 miles per hour. That probability is 11%, the p-value. Another way that you could say this, because again, this is two-tailed, that's why we're doing this other interpretation. Assuming the mean pitch velocity is 75 miles per hour, the probability the sample mean is, was it 75.7? Higher than 75.7 miles per hour, or it's two-tailed. So instead of being 0.7 above, it could be 0.7 below, and 0.7 below is 74.3. So higher than 75.7 or lower than 74.3. So the probability the sample mean is bigger than 75.7 or lower than 74.3 is 11%. There's a good chance it's going to happen. Do not reject the null hypothesis. Don't reject it. We're going to go with it. We don't believe this. The mean is not significantly different. The mean pitch velocity is not significantly different than 75 miles per hour. There we go. That's our hypothesis test.